Okay, and hello everyone. Thanks for attending ApacheCon. And good morning, good afternoon, and good evening to the people in the different time zone. My name is Qing Lan. I'm a software engineer inside of Amazon machine learning group. And today I'm going to present the topic for deep learning in Java and everything with learning and also Java language. Firstly, beforehand, I saw the people in the chat room saying they're not familiar with learning the concept. Let's go over the right-hand graph first. So what is actually like a deep learning? You may be familiar with AI, like the AI application people tell in the normal region, from the basic concept to do a simple dog and cat classification into the other task, like they're recognizing your handwritten digit, or like the feature Snapchat and Instagram brings that can actually putting a dog face in your face. These are all AI technology. And below that is actually the learning technology. It's a smaller domain inside of the AI because AI is very big. It contains the basic rule-based system stuff and also the machine learning task. And below the machine learning task is actually the deep learning region. And deep learning is a subset for machine learning. And typically, machine learning can be categorized as supervised learning and also unsupervised. And deep learning fall into the supervised learning by people feeding in the corresponding data, and it can generate for the rules. And on the left-hand side is actually the development trend inside of our current academia and also industrial field. So for the traditional programming side, at the beginning, people building up the rules simply by defining how you want to define this by writing up even the simple if statement. They can say if the people type in some kind of words, they're going to give them the corresponding answers. And this purely rule-based system has been long lasting for the first generation AI applications. And surprisingly, and I have even hear the rumors that people talking about Siri before 2012, they're also using the traditional programming by written up the 1,000 lines of rules by defining what the user trying to type and talk when they're talking to the agent. And after that, there are machine learning technology, and it's a simply concept that people can having the data and also answer feeding the machine learning models, and it can generate for the rules. It's a simple feeding algorithm. You can imagine a simple algorithm like y equals to ax plus b. And by feeding the corresponding x and y, they can use the feeding algorithm to find the best weight and bias inside of this algorithm. And the rules in here is corresponding to the w, to the weight and the bias. And by generating these kinds of the algorithm, by after that, they can just simply feeding up the data inside, and the algorithm will generate the best guess for the answers. And deep learning is also using the similar terminology that doing the supervised learning by having this in mind. I won't be going too much for the deep learning itself because our major roles in here is all about the deep learning itself Java. If you have any questions with deep learning itself, please raise your questions in the chat room, and I'm going to handle that after the session. And why Java for deep learning in our cases? And I saw there's actually like a trend inside the enterprise customers where they're trying to use Java for their deep learning use cases, because most of the services inside the world, they're actually building inside Java, like Tomcat-based services, and also the big data processing, like the people trying to use Apache Spark to solve their problem, and also the stream data processing problem. People are trying to use Apache Flink, and these are all built inside of the existing JVM domain. And also the existing Java existing Java API for deep learning is kind of painful because mostly they're kind of low level APIs, and also it is kind of raw for them to use. There are broken pieces, and the memory cost is very hard to keep. And also by having that Java API deploying your machine learning stuff inside of Java is also very challenging. Because if you consider with prod environment, you really need to keep the environment safe without any kind of memory overflow or the other issues like segfault when you're trying to do the multi-threading inference or training task. So its maintenance cost is also very high for the existing enterprise users they are trying to leverage on the Java. And the second problem is there's deep learning standard in the Java community. They are actually one inside of Python right for now. There are people trying to getting their API closer to the NumPy. But if you're trying to use a Java, like when you're trying to run with the different Java machine learning and deep learning packages, you will find that the standard for the Java is all different. And thirdly, deep learning with strongly typed languages. Because if you're trying to look into the code, especially written in Python, you will figure that the readability for the Python code isn't very good because they didn't provide us like the type of the data set. Although we can infer that during the runtime, but if you're considering with the Java service code, the readability and the reliability is truly important because we really don't want to make any mistakes before we throw that code into the prod environment and running for hundreds of hours. Right. So by having that in mind, I'm going to introduce you the toolkit that Amazon Web Services created called djl library, trying to solve the problem with deep learning in Java. So like the reason that deep learning and the djl library came in here is because there are actually teams now at Amazon. They ask us if there's a single solutions we can write, we can use Java in our prod system with all different kind of deep learning framework. And they have spent days and even months to build up their own Java API just to solve the problem to run inference in their prod system. And that is the initial reason why djl library came in here. And djl library is simply designed for Java. It supports for multi-threading. It also has the memory control system, and all the API signature are developed into the Java-friendly way, where you can do everything inside the Java way, and also having the benefit of doing everything that is actually for deep learning tasks. And second benefit is we're following the Java standard like write once, run anywhere. We have a single layer front-end API that applies to the all deep learning engine we currently support, like Apache MXNet, PyTorch, and TensorFlow. Whereas if you're trying to run an image classification task with let's say with Apache MXNet, and if you're trying to switch into the PyTorch, you barely need to change any part of the code. You only need to change your dependency import. And the same code can be run with different deep learning engine, and they will also have the same behavior. We also bring in something called Model Zoo. It contains 70 different pre-trained model out of the box where you can use them directly in your inference and training applications. And the models came from the variety of sources like Gluon CV, Gluon NLP, and also Torch Hub, Hugging Face, and also Keras pre-trained Model Zoo. And Amazon has actively contributed to the open source machine learning projects, including the following like TensorFlow, MXNet, and PyTorch. By learning from the community, we gradually understand what are the demand for the Java customers, and we finally build up the single layer djl library here, and also made it open source to benefit for the all Java developers and deep learning developers. And all the lessons we use inside is Apache 2.0 because we understand that the true open source that is actually fall under the Apache lessons. And we also supporting for different Apache projects, like we have the packages installed inside of Apache Camel. We have a close integration with Apache MXNet. And also we have the example integration with Apache Spark, Apache Flink, and Apache NiFi. And also there are upcoming other projects that are coming towards that we're going to bring to benefit for the whole Apache community. So now let's move on into the architecture for djl library. So firstly, djl library has a single layer Java interface that has been defined universal across different deep learning engines. So you can expect whatever you're going to write, you will have the same behavior across the different deep learning engine. And the first thing at first is called ND array. And the ND array here is n-dimensional array that representing some higher dimensional data set instead of a Java domain. The original array representation in Java is kind of weak if you're trying to use it to represent some complicated use cases. And also we have some other stuff like model. And inside of the model is essentially you can load and train the model with the two classes that spawn from the model cases. So first thing called is trainer. You can train the model with trainer. And second thing is called predictor, where you can run the inference with that. And also there's another key class we call it block. It's actually the container for the different neural networks. By having these three, it builds up the whole building blocks for you to actually try to run the training and the inference with Java instead of the deep learning domain. And below that, we have the Java engine layer, which corresponding to the different implementation inside of Java that corresponding with MXNet, PyTorch, and TensorFlow. In here, we're basically doing the translation work that are going to translate their original behavior to the universal behavior on the front end. And below that, we have the C++ layer. We have built or used the corresponding GNI and the GNA layers that are actually calling directly with the C and C++ API with different deep learning engine. This will ensure us to have the best performance comparing to Python, because we are all using the same API in here, and it will also bring us the same behavior if you're trying to run the training and inference tasks comparing with Java and Python. And we also support for different hardwares like Mac OS, Linux, Windows, and also even Android devices. And we support for both CPU and GPU use cases. And let's now move on to something that's really fun. On the left-hand side, you can actually see it's an Android applications. It's a doodle draw application that trained from the PyTorch with the Google Quick Draw dataset. And it will actually recognize the doodle you're drawing on the screen. Like here, I'm trying to draw like a rabbit in here. And below that is actually presenting the inference result where we're trying to run this kind of thing. And surprisingly, the total inference code inside of this Android application, the inference side is less than 20 lines of code, and it's also available from our demo site, and it's been running on the Android device smoothly. And to build up the djl library with the AI application is very easy. Basically, you really need to have much more machine learning experiences. We have the different packages ready for you to import, and also we have already provided different pre-trained models where and even you use the model that is already trained by using some other sources and import to djl library for your own inference and training cases. So, and djl library also supporting for the advanced use cases such as the training. It has been designed for the engine for the Apache MXNet and PyTorch. We have the fully data set that's supporting for both CV and NLP training. Similarly, we provide the different building blocks for the CV and NLP models. You can use the pre-trained model for the transfer learning or simply train from scratch. We also have the advanced feature like multi-GPU support. You can run with multi-GPU training, and also the transfer learning with your existing model. And apart from that, we also have the built-in metric system, which allow you to quickly collect the key information you want to get, like the speed of training, like the accuracy, and the loss information. So these are crucial for the training use cases to get a better representation about what are the actual outcome of your training workflow. And before we jump into next sections, we would like to introduce you some book that Amazon created for the different use cases. So inside of the Amazon Science team, we created the Dive into Deep Learning book. It contains 150 runnable Jupyter notebook from the model architecture to the applications inside of different CV and NLP use cases. It also adopted as a textbook and the reference book at UC Berkeley, CMU, MIT, and 70 more universities worldwide. It's been designed very easy to learn, and people with no deep learning technology, they can make a start in here by running with the Jupyter notebook and also following the flow that we want to teach about the different concepts. You will learn how you can creating like a simple neural network, like with a single layer, and also to the modern like the convolutional neural networks with the CV application, and also it contains the NLP information. So now we also bring something similar. We currently implementing the Dive into Deep Learning, this book inside of Java. And I think it's also recognized the first Java book for the deep learning in our use cases. And before the session started, I already put the link in the chat room where we can check it out. And we currently finish up the first 7 chapters that all designed inside of Java, where you can use Deep Java library along with the book to learn the basic use cases with deep learning itself and also the Java technology. And we're trying to make this book as an industrial solution for the deep learning use cases because for its simplicity, and also for its advanced usages. You can check it offline after I can also share the slides. You can check out this book. It's very useful. You can run it online and also locally with your own Jupyter notebook. So there's a lot of fun to do that. All right. And now let's move on to some real meat. How Deep Java library solve the deep learning solutions for the customer production use cases. Before we jump into that, let's talk about the key advantages that Deep Java library actually bring. Firstly, it's very easy to set up. You can just simply write 10 lines of code to run for your inference task. And for sometimes it's usually lasts below like 10 to 20 lines. And I would say most of the cases won't be more than 20 lines of code. And it also has very minimum dependency requirements. You can expect if you want to try to use MXNet, TensorFlow, and PyTorch, the total dependency for it to import is only 2-3 different packages, with the total package size less than 200 megs. And Deep Java library is designed to be very fast, especially on the Java service. It can get up to 2 times performance boost on some small model inference. And the terms for the small model in here means the model has less of the features, such as SqueezeNet. We have benchmark on the SqueezeNet. It can bring us 2 to 7 times performance boost if you're trying to run it on the server comparing to the existing model server solution. And this technology has been used widely by the ads and query understanding inside of Amazon, and also some small image classification from our external customers. And besides that, Deep Java library also have the support for the large scale, where you can run the offline data processes with more than 800 million inference load with Apache Spark and on a cluster of machines. And also you can try to use Deep Java library with online streaming tasks, such as you can use Deep Java library as a middleware inside of Apache Flink. Since it's a Java package, so you simply just import this package and do all the inference tasks. And we also provide the corresponding examples in our demo site where you can try that to get the integration. And finally, the key reason that people choose Deep Java library is because it's very stable. We have doing the consistent continuous inference call based on all different releases we're trying to bring there with more than 100 hours benchmark tests. In the real production use cases, we really don't want things crash, right? If your inference or training service is continuous crashing, you won't be thinking this is the reliable solution you want to choose. So we want to keep it very stable. And the long-lasting service we have been now, it's been lasting for more than 60 days. without any problem. So let's jump into the first use cases by djl library on Apache Spark. And again, it has very minimum dependency requirements, which can actually save in times once you're trying to run everything inside of a Spark machine. And apart from that, the multi-threading support now came into place because the Spark, they have been designed every part inside of the multi-threading. So you can leverage that benefit with djl library. Since we already support that, you can use multi-threading with JVM inside of Spark. And if you're trying to compare the djl library solution, it's actually much faster than the multi-processing solution by leveraging PySpark on small models. And here we mentioned about small models again. So if you're talking about some large models, such as the BERT model, it's usually like 800 max to 1 gigs of memory, and total inference cost will last around like 200 milliseconds. So we kind of having like 10 to 20 milliseconds performance boost if you're trying to compare that. So the benefits is crucial inside of the small model side. And the djl library is also designed to be very easy to use. You can leverage our plugin with HDFS and S3. You can load the model directly from these domains, so you don't worry about where you want to store the model and how you want to clean on the models. And this kind of stuff is being used by the Amazon retail system and also the Chinese firm called Talking Data for big data processing. So the story from the Amazon retail system is, before using djl library, they spent like several weeks trying to fine-tuning their models and to deploy into their inference service. And the total inference time is around like 24 hours. By having djl library built in there, they can leverage with different deep learning model easily without spending much of time into the tuning on the memory. And the total inference time has been lasted just inside of 8 hours on 800 million of the inference workload to provide the best provide better experiences once the user trying to search on something. And for serving solutions, djl library is a Java-based solution. So you can integrate that with your existing services by simply import the package and use that directly. And this technology has been used by the Amazon Ads team and also Netflix. So talking about the Amazon Ads use cases, before that, there's actually a team came into us like saying, can you help us? Because we really have a very critical task we want to solve. And they want us to bring us solutions that can run the inference inside of 1 millisecond. Because their ads query, they require very low latency cost. And all the existing model service solution cannot solve their problem. And they came to us and say if there's a solutions. And we have been trying on that beforehand, and we didn't know there are even customer asked like that asked us. So we do the benchmark. And finally, the outcome is always surprise us as well. We finish all the tasks for their model inside of 400 nanoseconds. It's like half of the millisecond. And they're also like very exciting about this result and now moving to prod. So you can expect like all the query when you're trying to search on the Amazon ads, we run this crucial services and bring you the inference result by bringing you the sponsored product. It all came from this kind of services. So so I would say that djl library is also very tough into the use cases if you have really tight budget in your inference use cases. So that's pretty much about the djl library's introduction. Since time is tight, I won't have so much time to introduce our stuff. So if you want to check it out, please go to our demo page, also our website. And the djl applications is also available in the Google Play Store, where you can try to download that and test it locally. And please feel free to tell us any problem you're having when you're trying to play with that application. So thanks for listening. Okay, right. So let's actually, okay, so I hope my flow isn't going very quick in here. So is there any questions or anything? So let me try to bring up the questions. So basically, thanks, guys. Oh, how can I start a notebook of deep learning? Good question. So basically, there is a solution that Frank actually posted below, above in the chat room. I will just paste that link again. You actually can make a start with our D12 book, which this book brings you the basic terminology where you can learn from scratch for the basic deep learning concept, as well as the like how you can leverage deep learning inside of Java. So this book is still under development, and we're hoping if there are more contributions, there it's actually welcome because we're open source and yeah. And we only finished currently like 7 chapters, and we're hoping we can finish all the book this in this winter. So you will have a comprehensive, like the first book that's been decided, that's been defined in the deep learning world with Java. How to use deep Java library with MXNet, comparing to use MXNet Java API directly. Okay, so I think I'm the person to answer that question. So I'm also the MXNet Java author. So basically, comparing that is deep Java library is the second generation for the deep learning stuff. For the MXNet Java and for MXNet Java APIs, we actually brings too much of the old schemes, like you actually you using a lot of deprecated feature inside, and also because it's actually like a problem because we firstly defined the MXN Scala APIs, so we actually building up the Java layer on top of that, and we began to feel like the sick nature for that is not very friendly for people to use, and also people find it hard to do their memory management with the MXNet Java APIs. So beside of that, so that's why we're trying to leverage with the second generation Java part in here to bring up a better Java experiences by having the deep Java library implemented in your Java API here. So you can think about that. So the deep Java library with MXNet is actually bring much of the features. We're using the same operators as Python use. We provide the similar NumPy experiences, and also it is support for both imperative and symbolic inferences, which MXNet Java cannot bring. And the most important question is very designed to be very simple to use, especially on the package management. Before that, if you're trying to leverage with MXNet Java API, is kind of painful. I would say even their team saying it's very hard to use, so we always spend too long time to help people to onboard with that packages. So yeah, I hope that answers questions. And the trade-off is I always think there would be basically no trade-off if you're trying to use deep Java library. It basically what's MXNet Java API can bring deep Java library with MXNet can also bring that. So yeah, and also it's in sync with MXNet 2.0 with upcoming features that happened by the end of this year. Right. Any more questions from people? Okay, I will wait for another 5 minutes. So this will be the end of my session after that. So have you worked with pipelines? Which pipelines you actually mentioned here? So I'm not quite understand. Can you explain more about like the meaning of pipelines? You mean the Amazon Web Service pipeline or some other pipelines? Oh, sklearn pipelines. Nope. The actual answer is nope. We haven't worked so much on that. Yeah, I will definitely take a look on what is sklearn pipelines. Do you know what are the key benefits by having that inside of Java? So talking about that, we're also supporting for the Onyx runtime, which actually bring us to import sklearn model directly inside of Java domain. You can basically convert your sklearn model into the Java and then run the inference cases in there. So I would definitely take a look on sklearn pipelines. Yeah. Okay. So thanks again for everyone. Thanks for your time, especially. I would say that's really hard for the people who is in the China region and also inside of the West Coast because it's very early in the morning and very deep in the evening there. So if you got a chance to learn more, so and thank you everyone to join this session. Right. Thank you. Yeah, and if you have more of the questions, please feel free to go to our Slack room, and I'm going to answer the question there. So I mean to keep us connected, because once I guess the session ends, there won't be any chance for us to actually see the questions you actually ask. All right. Okay. Any more of questions? So yeah, so pretty much this is the end of the session. So if you have if you just lose your chance to get it through it, please join our Slack channel where we can answer the question there. And probably since this session is also recorded, I guess it will also be shared once the session's end. Please do doing that catch up. And also go to our Deep Java library website. We're also providing you like 10 minutes basic tutorial about what deep learning is. They have the similar content in there to understand what we actually covered instead of these cases. Yeah. Okay. So thanks everyone. I'm going to close the session. And if you have more questions, please go to our Slack room and Slack room. If you have more questions, or go to djl.ai to understand more. All right, so see you guys. Bye bye.